Hello, everyone, and welcome to today's Insight Live, the expert's take. I'm Jason Rader, and I'll be your host as we go through the topic of data and AI modern applications today. With me, we've got an old friend, Carb Taglienti. Welcome, Carm.
Thanks, Jason. Great to be here.
I'm glad you're here. And Carm is a distinguished engineer here with us at Insight, specializing in data and AI. And we would like to send a get well out to Amal, who would have been joining us, but he's not feeling well today, so that's okay. Although I would have liked to have had him in the ring with us as we kind of go through this particular topic. So to throw the grenade out there and start talking from a data perspective, because as we had a pretty heated prep for this when we talked about it last week, and not heated like argument, but heated like, wow, big picture kind of stuff related to data and our philosophies on that. So I think that's where I wanted to go. And we marketed this kind of as the data dichotomy. What are we saying when we say that, Carm?
So I think in a lot of ways, when we think about data, most people think about it as something you collect, something you save, something you store. The idea here, I love this term. I used to call it dark data, and it was basically companies store all of this data. They're like, someday we're going to be able to use it for good, and it sits there. So there's lots of storage, and we create a data lake, or sometimes we call it a data swamp these days as sort of a joke. But in general, companies tend to do a good job of collecting data, but not a good job of using data. And I think in some ways it's because of the fact that don't really realize the assets that are available to us and curate them in the right way. So I think some of the dichotomy is related to the first part of it is understanding exactly what data we have and then understanding how we can use it to good effect. And then also knowing that there's a commitment to curate it, because when you start using your data, how do you actually make sure that it is valuable or viable to the kinds of problems or questions that you're asking of your data? And so those are some of the things that we deal with. And I'll get to the big data concepts in just a little bit, but around velocity and connected devices and generation of data and all that other good stuff. But in general, that's kind of the dichotomy that we think of. And one last point I'll add, so we give us a little bit of, I'll give you Amal's perspective as we talk through this. It's really just focused on how do you surface it? How do you take the information that you would gather, for example, by creating AI models and other things that we can also talk about, but then how do you use that to be able to drive decision making? And so how do you make it available to the connected device, or how do you make it available to the business consumer in an easy way without having them go get a PhD in data science to be able to understand how to use the data? So that's kind of that dichotomy, if you will.
So that should keep us busy for about 3 to 6 hours, I would say.
Exactly. Right.
And I always like to break these down into stupid kind of Jason analogies here, but I think of it as like when I've got tons of stuff, I acquire lots of stuff, and my garage is this big repository of the stuff that I've acquired. All of it was not free, or none of it was not free. Wait a minute, none of it was free. How about that? Let me get the correct. And some of it I use over and over and have used for years. It's the Christmas decorations or those things that are quite curated. They're packed away. I know what's in them. They're labeled, those kinds of things. And I know where I put those things. Other things that were way more expensive than Christmas decorations are kind of not filed or stacked, and other things are stacked on top of them. And I think there's kind of a great parallel between that is we run into loads of organizations that they feel like what they need to do is to just stacks and stacks, that swamp paradigm you were talking about, of data, and there needs to be that rigor. So I guess as we kind of start with, so that we can use this, what kind of governance do we need to think about from a data perspective? Because there's two ways to this. First of all, any organization who's been around for any time has a full garage, just like what I'm talking about, right? Mm-hmm. And that, man, my garage is like, man, I just want to pretend it doesn't exist when I have a free day, because I don't want to start tackling that thing. And I think a lot of organizations, they want to make this jump. The AI is exciting. They can leverage it in their business. There's some good stuff. Where do we start? So I think that is kind of where you define that governance. So at least moving forward, we can start labeling stuff and put it at the right place in the garage. And then we can figure out how we do with the back
right
things.
Right. Yeah, I love the analogy, and it really aligns really well to governance. And so if we think about it, and really there are two major concepts I think that you're describing that are important to us. The first one is asset valuation. So it's like when you put that stuff into the garage or your data assets, can you associate a value with them? And if you can't, you probably then can think about it as, well, maybe I put it into the long-term storage area, or this is about to go to the, to charity.
Goodwill. Yeah, exactly.
Right, exactly. Um, but the ones that are most valuable, we not only think about in terms of decision making, but we also think about it in terms of, something near and dear to your heart, securitization. So those are probably corporate IP that should be not only tracked for decision making purposes, but also protected from, nefarious users that may want to access that data. And the second part is data lifecycle. So really understanding what the data lifecycle really is. And so while it may be important and critical to us today, is it critical to us in the future, or does it lose its value over time? Like, what is the half-life of my data or my information assets? And so part of that governance strategy is classification of data. Well, first of all, identification of data, classification of data, and then understanding the life cycle. And so that's kind of how I would think about it. But you're right in that the data is sort of the underlayment of making this happen. I mean, in a lot of ways, people want to talk about AI and they're like, oh, let's get to the cool predictive stuff that we want to do. But then they go to try to start make decisions and they realize, ooh, you know what? We don't really have good information to make those decisions, or the decisions aren't accurate enough to be able to really rely on them, so that the value then is much less than we would expect it to be. So it all sort of aligns to that underlying data. But most people, it's kind of like finding the best plumber in your house. It's like you just want someone to sort of create the plumbing. You're not going to pay the best. But when it comes to fixtures, you're like, oh, I need the gold-plated fixtures because those are so nice. But it's those analogies. I think while they may sound kind of silly, they're very accurate in this kind of an environment.
No, I like your plumbing analogy. That's brilliant too. The So I still think, first of all, I kind of talk about data from a classification perspective. Data classification is hugely important. And again, one of those things like plumbing, nobody really wants or cares about. It can cost a lot of money and effort to define a classification schema and to find all that data and to classify it appropriately, to train your people, all of the things, the due diligence that's required to get to that point of where now you're ready to accept new stuff and tag it appropriately and those things. It's really hard to get back there. So what I try to do for organizations that are starting out is I use this Venn diagram from a security perspective, at least. That is, this is the data that you need for your business. You probably know where that is because you couldn't operate without it. So that's an easy one to kind of figure out. Then we overlay in the Venn, this is the data that adversaries want, and realize it's not a one-to-one. There's stuff that you probably don't need for business that adversaries would like to have, old source code, those kinds of things. Where those things overlap, you're probably protecting. Where they don't is probably a gap for you from a security perspective. And then the third Venn is regulated. To your point, things that are regulated data. Where all three intersect, crown jewels, you're probably all over that. But then, regulated data that you're not using for business, that adversaries want to get, why do you even have that data? And I think that's one of those things from a life cycle perspective that is people have to kind of call into question. And this is me as well in the garage story. There's stuff that I really intend to use, but I haven't used it in the over a decade I've lived in this house, and it's sitting in the garage in the same spot. So what's the exercise that kind of needs to go in from a data perspective to get, let's say we're jazzed up on an application of AI that we want to use for business. We realize that we've got a bunch of disparate data sets that aren't aligned from a data perspective. What do we have to do?
Right. So I think the always the beginning of the data science lifecycle is the business problem. So first of all, understanding what is it that we're trying to solve, or what questions are we trying to ask of our data, so to speak. And you might say, okay, in some ways, maybe that's a reporting problem, but reporting is really nothing more than a simple version of more predictive style analytics or more statistical kinds of analytics that we would typically run. But AI is kind of the way that we think about things today, because we would love for the machine to make recommendations for what we should do. And it's entirely possible, and certainly something that's become more democratized, and we can move in that direction. But the next step really just focuses on understanding the sort of the ontology of the question or the data domain that's associated with that problem. And so that's where we get into the point where we say, okay, well, what kind of data do we need? What's the semantic value of that data? And then where am I going to get it? And as I go through the process, then you start to uncover, you know, this is the quality of the data. This is how well it's aggregated. This is how complete it might be. This is this is how we define it, or do we even have common definitions of that data so that I can use that to then sort of formulate the question so that I can use machine learning techniques to be able to say, okay, I can identify now correlations between either known outcomes, or maybe I can do some clustering around what are the common patterns in general within that data that will help me to understand the data better. And so that whole process, I think, is really kind of that next step. A lot of organizations, not a lot, but I think sometimes we think, well, do we have to boil the ocean? And sometimes you might say, yeah, I would love to build a warehouse and everything be pristine before I start. Well, we'll never get going. It's kind of like organizing your garage. Well, guess what? You're probably not going to organize your whole garage. You're just going to kind of make the part that you use the most clean and efficient so that you can accomplish whatever project you're working on at the time. Data is the same way. We tend to do it, but if we take a disciplined approach to being able to organize our data so that we can drive the decision-making process, then we'll find that as we evolve into, say, more sophisticated techniques, we'll start to improve the overall quality of our data. And then when we become a more data-driven decision-making company, then we'll start to think about, well, data truly is an asset for us, and we'll kind of change the way that we think about data, and we'll capture it in the state where it's highly governed from the get-go. So, those are evolutionary concepts, but in a lot of ways, I mean, the challenges that we think of today is, we try to boil the ocean initially, and we don't kind of get there, so we give up. But we can't do that.
Yeah, and I guess part of me is, back to the whole garage theory. There's a certain point where, okay, I thought I was going to use this. I'm never going to use this. I need to get rid of it. It's a liability to a degree. From the aspect of what we're talking about with new techniques, with data sets that you probably, how historic they are, probably if we're not like in agriculture or something like that, if we're trying to do something new and it's a new facility, or depending on what the application is, obviously. What I'm saying is it completely necessary to go back and I think you already answered this, but I'm just clarifying, and grab all of this old data, or is a newly acquired data that is formatted and governed appropriately, that probably can help us from a model perspective and get us 80% there.
Right. Right.
Is that fair to say?
Yeah, it's a good point. And a little bit of it is an ROI discussion, because then it's sort of the how much investment would I need in order to make this data fit for purpose, if it currently isn't. So then you might actually just weigh the benefit of, do I acquire data from maybe a third party? But if it's not possible to acquire from a third party, then do I make that investment, and is it worth it in order to be able to make the kinds of decisions that I'm trying to solve?
Yeah, because I mean, there's already models that are out there that you can acquire. You don't necessarily, but I think, and then you can apply additional data to them, and then remodel. So I guess that, like you said, is how much of a cottage industry is that? It sounds like that's probably a big business for folks these days.
Well, I think the model patterns, I think, are pretty well known, and so what we see is that for particular types of industries or purposes, different models will provide different kinds of capabilities. But in most cases, every company is different, and so the way that your particular set of data or the questions you're trying to ask or answer, how they relate to the model output is really requires somebody to be able to analyze it and determine how closely does the data represent the expected outcome? So you might say, in most cases, you might say linear regression is probably the most popular technique that most people use. I mean, it's pretty simple. It's more statistical in nature, but we think of it as AI to some extent. But you might say, okay, I really just want to kind of predict the future based off of historical outcome. No problem, I can do that. But what you're predicting is really up to you, up to your company. And so the data itself is really the important part of it. The kind of regression that you use, logistic, linear regression, those are things that you might say you really have to understand the data a little bit before you can pick the model that will support it. But none of us are going to say invent a new version of, regression analysis, because we're not, well, most of us aren't mathematicians, but in general, we're probably not going to sit down and say, let's just create a new version of regression in order to support our particular business problem. So we'll use existing models, but that's also a complicated thing to do these days too, because there are hundreds of different types of modeling techniques. You really do have to understand what's the data that you have available to you, what's the shape of the data, what is the kind of problems you're trying to solve, and what's the tolerance that you have for accuracy in terms of predictability or correlatability of the model. That's a funny word. But in general, that kind of is where the data sciencey type people come into play, or people with heavy business understanding, so that you can take a look at the model and say, the results of the model do align to my hypotheses. And once I align to the hypotheses, then I can say, yeah, this model actually is pretty good in terms of being able to help me to answer those particular sets of questions.
No, I love that. Earlier, you made a comment about the difference between a data scientist and a data engineer. Why don't you kind of roll through that? Because I think that's a good distinction.
Yeah, exactly. And I was kind of describing just a minute ago data science, but a data engineer in my mind is really just someone that's more lives in the data, understands the curation of data, governance of data, and they're very good at it, very disciplined in terms of, just like an engineer is just sort of steeped in principles and um, structure in terms of approach. Not that a data scientist isn't steeped in principles and approach, but there's a lot of discovery associated with the scientific world. It's kind of like a researcher in science. Well, researchers have hypotheses and they try to validate them. Whereas an engineer says, I'm working in the physical world or something akin to the physical world, and I know exactly the techniques that I can apply to accomplish these specific outcomes, and I go forward with that. And so, and that's really the difference I see in the way that we apply this. And so, somebody that is steeped in the tools and technologies is going to be great at data engineering and sort of help you to curate that data, whereas a data scientist is going to align more to the business and really just understand, how do I create hypotheses, or how do I help to align the data and the models to be able to solve your particular problem.
So would it be fair to say that a lot of people who think they need a data scientist potentially need a data engineer as opposed instead, or because that's what the vibe of, right?
Yeah, well, that's a really good point. So if last time I checked, maybe it's about a year ago, I'm sure it hasn't changed. Data scientist, I think there were 9 different definitions, and they go everywhere from very specific hands-on with tools around data to, do you know SQL? Do you know how to structure a schema? All the way through to, do you know how to, can you code a Bayesian algorithm? And do you know how to interpret business results? So there's a bit of a Venn diagram there as well. So you've got business skills, you've got technology skills, you've got actually hacking skills are part of it as well. Yeah, exactly. So it's an interesting dynamic in terms of the way that we define data science. But I think what we see over time is we see a bit of a stratification because of the maturity of the field into more engineering disciplines versus scientific disciplines. And they both can be optimized and used to advantage within the organization.
Yeah, and I think, again, depending on how we're delivering back to the business, this is just kind of a Jason observation, always kind of from a transformative perspective of an organization. I usually think of a specific part of the organization that's right in the job description for the data scientist that they need. where I think that there's something that transcends from a data perspective, a lot of different parts where everybody else should be able to weigh in. It's not necessarily those SQL skills that are going to be nailing it 100% for what the role that this individual is actually going to play within the organization. It could be a lot of leadership involved in actually doing some of the stuff, or even the hacking skills. I thought was a valid point to bring up, because you're literally having to hack data. You're having to find it and cobble it together to kind of serve your purposes. And that's an interesting angle on that. But I think it's, as we kind of distilled everything in this conversation down, we wanted to talk about AI and modern applications. It was really like data is the focus of all of this stuff. I mean, it really is the key. Whether you're leveraging what you've got and cleaning it up, putting governance around it, how you acquire it now, how quickly you can leverage it in that case, format it and get it into the systems, and then leverage those outcomes. That's all, again, that's well beyond what the data scientist does as well. That's part of a business, that's part of dev, that's part of go to market in some cases. I mean, there's a lot to it. So this is one of those things that it shouldn't be relegated to just as very, tunneled part of your organization when we're thinking about it.
Right. And it's a really good point, because as we relate the whole concept of data science to usability or surfacing the analysis, that's where the application world comes into play. So in a lot of ways, in the early days, and again, I'm dating myself, but in the early days of data science, when we first started doing a lot of this work, we would work in little lab environments and little exploratory environments, and come up with models that could represent the kinds of domain and questions that we wanted to have answered. And we could do a really good job of it. The problem was it wasn't very repeatable. And then when we produced a model, the half-life of the model, so to speak, was very short, because we didn't really understand how to identify either the amount of data that was required in order to create a more persistent model, or how do we factor in the tolerance of the model for different kinds of perturbations in data. So I think over time, though, it's become more mature in terms of our approach. But then we also have to think about what's the usability. So for example, we've done work with hospital organizations in the past where we're trying to understand how can we best provide advice to doctors when they're meeting with patients based on, a various set of things. It could be something like, what are the recommendations for types of medicines that you should be taking for a particular type of disease, for example. And we have a lot of data, we understand the patient's profile, et cetera. But if we have to, pick up the phone, and the doctor has to call the data scientist and say, oh, here, these are the three things that I see with this particular patient. Can you run the model for me and tell me what prescription I should, make for this individual? Well, no one's going to do that. So if we can, though, integrate it into, create services, integrate them into like an Epic system or another patient facing system, and provide that to the doctor, then it becomes that much more usable, and it increases our viability. And going all the way back to our initial discussion, it increases our ROI, so that we can say, oh, you know what, in order for us to be able to curate this data to provide better recommendations to our patients to increase their longevity and the patient experience, we have to invest more money. Well, guess what? Now all of a sudden we're providing a huge amount of value, because we're now surfacing those results out to the directly to the patient. So that all kind of is like a virtuous cycle, I guess, in terms of how we look at it, because then we're sort of promoting the value of the data by leveraging its the analysis that's done with that data. So it's really interesting, and I think eventually we kind of merge all of this together, especially with democratization of AI, because we think about it more as, I don't need a PhD to help anymore with this. It's great to have a PhD, but you don't require one. We have AI services, we have different types of service that'll do things like voice recognition or text recognition or object detection, or models that are trained to do predictive analysis related to failure of components. There are other types of models that are very attuned to the kinds of behavior that we're expecting to monitor. So I think the more of that we see, the easier it becomes to surface this into the external world without requiring speciality in this particular area. But I don't want to sort of, talk myself out of a job here, but we might see something similar to that in the future.
No, but I love it. And I love that democratization of data kind of concept in AI is, it is true. I mean, I remember having to go, dating myself, to the computer lab to compile my code and print it out on the green bar paper and all that stuff. Now to leverage a massive infrastructure and disparate data sets from all over, and to run that model, I can do all of that from leveraging a cloud service, and I mean, for a ridiculously cheap amount if I were like literally paying for it myself. And I do think that it gets us to that end result quicker. Now, whether or not the quality of that data was valid, that's a whole nother thing that we got to talk about, because coming to an answer really quick doesn't mean that it was a great answer. So how much you trust that based on the back end data is a really good point too.
Yeah, it came full circle, right? Because it comes back to the data. So it's like as much as the front end could be done for us and it'd be more automated or more convenient, it all comes back to the quality and integrity of the data that we have available to us.
Well, so, this has been a fun conversation. Where do we, so overwhelmed people, I feel slightly overwhelmed on the topic, who are watching this and are like, man, where do I start? What's a good place to start? And I know you teach at a university level and those kinds of things. Where do people start? Is not go back to school? Is that the only answer? Where's a place that a business, and I think, Juan, somebody we both work with, loves to say, figure out a small project and kind of expand from there. Is that the solution for this as well? Or what's your advice?
I think for the individual, I mean, there are plenty of these micro courses that are available, like Stanford, MIT, that offers these data science or introduction to data science courses. So as an individual, if you want to learn more, you can start there. So just basic model programming or learning about data science, and you'll use plenty of models. And these courses teach the entire life cycle. So they teach all the way from data acquisition, data curation, data shaping, data exploration, using and training models, and then sometimes deployment of those models. So I think that's one place to learn. The other place is, if as an organization, if you're looking to say adopt these kinds of techniques, well, there are clearly patterns that are available, but the cloud services are really a good place to start, because a lot of the cloud providers, or even other I'll call them ISVs, produce products that are really data science workbenches, like the Databricks of the world, just as an example, which help to facilitate the process of creating models, curating data, and then creating a pipeline that allows you to be able to sort of take what you've learned and then move it into production in a convenient way. And there are lots of different techniques, even in the open source world. But those are a little bit more complicated, because at that point, then we're talking about sort of major systems within the organization, in order to get them aligned. But it does reduce the barrier to entry, because these patterns are well known. So like a Databricks is a good example. So it's sort of a predefined workbench model. Or you can go to Google or Microsoft or IBM or AWS, and there are, this is how you do data science. This is how you create an ML ops pipeline. This is how you create a data lake. So there are patterns that will help you to get there. And of course, we do that too. So there you go.
Oh, I love it. And I think, if you kind of distill just about any business problem down, I always tell me what you're solving for. What's the problem here? Some people have already kind of designed the way that they think it should go, or they design it around the current way that they do it. And that's not always the best way to kind of look at it. What's the problem that we're trying to solve for? And I guarantee you, in most business cases, probably in all, but I'm hedging my bets, there's data that's going to be needed to solve that business problem. Even if it's just very simple data, yes, no, or something along those lines, it's all kind of back to data. So what I would say, business leaders out there, wrap your head around the types of data that you collect, the governance around that data is something. Now, if you're not thinking about that, you need to start thinking about that. That's a really important aspect of how you're going to move forward. Even if you really don't know that problem you're trying to solve, at least try to figure out some governance around that data from a security perspective in general, but just how you're storing, formatting, systems, those things.
Absolutely. Yeah. And I would say the biggest epiphany for me when I first started getting involved in the space was a term that's called, or a technique that's called, exploratory data analysis. So it's the first time you actually get to see your data, to visualize it, to understand like, where are the outliers? What's the consistency of the data? It's a true epiphany, because you look at your data and you're like, I didn't think it was that bad, or I didn't realize we had, so much whatever incidents of this particular type of event. So it is kind of amazing, and it doesn't require sophisticated AI techniques. It really is just something as simple as creating, a scatter plot. So if you are able to collect your data and really get quickly to the visualization side of it, you can visually see outliers. It's not going to solve all your problems for you, but at least it points you in the right direction and helps you understand the magnitude of the challenge or opportunity that you have available to you. So it's really a nice way to start. And we use the technique quite a bit in terms of helping customers to understand what is the extent of the opportunity, because how else than to actually see your data than to, you're not going to go in and talk to somebody about, we're going to guarantee that we can predict, the future outcome of your business over the next, 10 quarters. That's, if I could do that, I probably wouldn't be, here talking to you. I probably would be on an island in Bora Bora or something. But in general, this is the idea. So it's, it really is advantage. It's a big advantage to organizations to start looking at their data, to understand what they have, understand the magnitude of the challenge or the opportunity, and then start from there.
Yeah, I think standard consulting methodology. Okay, here's the problem we're solving for. Let's do an assessment.
Yep.
And figure out where we're at, and then how do we fill these gaps? How do we get to this, conclusion that we're looking for? So I love it, and that's what we do. Well, Carm, you rock. It's been a fun time talking to you. Thanks for today. For you folks out there, we love you guys. We appreciate what you do and the comments that you offer. It's a good time doing this kind of stuff. We'd love to get your input. If you want to know more about what we do, or talk to somebody who talks like us, please feel free to visit us at solutions.insight.com, and we'll see you next time. Thanks, everyone.
Great. Thanks, everyone.
Thanks, Carm.